All right, and we're live. Yes, excellent. So yeah, it's been weird because I haven't had an actual lesson with you guys since Tuesday of last week. If you think about it, Tuesday of last week we did something, and then Thursday we hit I don't even know what to call it, rain. So they shut it down for rain and wind. And then, so I wasn't able to teach anything new. So I had to assign you something out of the textbook, which I did. And then Monday, of course, it was the benchmark. Oh, yeah. Monday, of course, was the benchmark, which we knocked out, which I will have to be contacting people in regards to that. Just to give you a heads up for when we come back. When we come back, I need you to think about this. We will only have 7 class periods until midterms. I need you to think about that. When we get back, I will have you on that Tuesday, Thursday. I believe that Monday, Wednesday, Friday. And then I believe the 18th we have off of January. So then I would have you on that Wednesday, Thursday as well. 7 class periods until the midterm. Don't know what day of the week your midterm is going to be, but I just want you to be aware of that. Of those 7, probably 1 or 2 of them are going to be review. So in reality, it's like 5 or 6 class periods until we review for midterms. Fun stuff. So with that, I do need to review with you certain pieces of information that we haven't seen for maybe a week or so. But I need to review that information with you. We need to get back on top of this stuff, and that's what I want to do. So if you would, if you do not already have them out, I'm going to need those notebooks out and open. I keep hearing bad words. Y'all hear bad words? I hear bad words. Let's see what we got here. So I'm going to call this Function Operations Review. I believe I've started all of the conversations in bad language. I don't think they can hear anything that I'm saying. Oh, you did? Oh, didn't seem like it. You guys okay? I like to whisper too.
Hi, how are you doing today? No whispering.
Let's review something here. Now, again, this has been like over a week since you've seen this, but I need to make sure we're on top of this information, especially with the composition function that we learned way back when. Now, I'm going to give you 2 functions here. Let's just say P of x equals 3x plus 4, and Q of x equals 2x squared. Let's just go with that. Now, P and Q, it doesn't matter. It could be P and Q. It could be F and G. It doesn't matter what it is. Those letters are just simply the names of those functions. That's the P of x function. That's the Q of x function. And they are programmed to do a certain function. The P of x function is programmed to multiply the input by 3 and add 4. The Q of x function is programmed to square the input and then multiply it by 2. And I might take something along the lines of, I don't know. Let's say Q of P of -2. And I may say, hey, evaluate that. Evaluate that. Now, I could probably give you a few minutes, and you could think about what it is that you have to do. And I guarantee you probably about 25% of you would put in fair attempts at getting this answer done. The other 75 would just try to look like they're busy. Don't deny it. Anyway, but if I asked for an actual answer to this question, I dare say a few of you might be able to actually do that. Absolutely. Now, guesses aside, let me show you a few different ways that you could potentially get that problem done. Actually, let me show you two specific ways that you could get that particular problem done. Two ways. First, we could identify what the function q of p of x actually is. The order in which these letters are written make a big deal. Well, I'm going to put equals question mark right here. There we go, because we don't know what that is. But first, I'm going to try and identify what q of p of x is. Now, just to take you back, because again, it has been 8 days since you've seen this stuff. And in those 8 days, tons of stuff have happened. Did he give me an answer? Oh, he said hi. I thought he gave me an answer in the chat. Never mind. But if I'm going to do a composition function, the idea of a composition function is taking one function and literally putting it inside of another function. In this case, it's the p of x function that is going inside of the q of x function. You are literally taking whatever the p of x is, in this case, 3x plus 4, and you are inserting it into the q of x function. And you would do that in the following way. Now, first of all, what does q of x do? What does q of x actually do in terms of our problem? What's it programmed to do? I can hear the crickets. Oh no. That's what p of x does. I said q. 2x squared. Now, I want to talk about that first because it's the outside of the function. Check this out. 2x squared. Look at that. I just wrote out 2x squared. No, you didn't. Yes, it did. I wrote out 2x squared. Except instead of the x, I left it blank. For those of you in the chat, there's a giant glare right on the spot right here, but there's nothing written there. I'll move the paper in a moment, but there's nothing written there in that blank. Move it up a little. The reason being is because that is the outer shell of this problem. That is the outer shell. The q of x, the 2x squared, the 2 times the input squared. And what's going inside of that blank is the p of x function. The p of x function is what is going on the inside. In this case, 3x plus 4. That's what's going in that blank. Now, I could simplify this. Just for the sake of argument, I'm not going to, just because that's not what I'm trying to teach today. Trying to refresh and review on what the heck composition functions actually are and what they do. Function notation, all that wonderful stuff. But for the most part, this is q of p of x. P of x being inserted in the inside. Now, that doesn't answer our question because I have that question mark up there. That question mark saying, okay, what's q of p of -2? All that really means is this. Oh, I can't see it. It's frozen like my heart. There it is. Now it's better. That -2 is going to the heart of the problem. And I'm going to take that -2 and I'm going to insert it where that x should be. And now all I have to do is follow an order of operations in order to get this question done. If I follow that order of operations, I got to take care of what's inside of the parentheses first. In this case, it becomes that, because 3 times -2 plus 4 becomes -2. Squaring it will get you a +4. And multiplying those together will get you a +8. That's one way of doing the problem. I'm going to show you an alternative way in a moment. But for the most part, Q of P of -2 is equal to +8. That's what that thing does. Again, this is just one way of thinking about the problem, one way of actually manipulating the problem in the way that it should go. I have a few more examples for you in a little bit, but let's try this first. I want to create a little bit of a table. Here. And this table is going to go in the order of inside to outside. In this case, I'm going to have an X here. I'm going to have a P of X here. There we go. And then I'm going to have a Q of P of X here. Create a little table. Now, the number that I chose to plug into this thing first was -2. I chose that. Where'd it come from? My head. That's just where it came from. And the P of X, same exact function. I have not changed a thing. The P of X function was 3x plus 4, which in this case, if I plug in that -2, that spits out, well, another -2. That's just coincidence. That is pure coincidence that happened. The ordered pair in question was -2, -2. Hold on, who's calling me? Who's in trouble? It's Marcy's room. Okay. Bye-bye. Nick. Can you hear me? Nick. They need you in guidance. I was purposely whispering. Hold on. Where's my pen? There it is. Yep. Okay. So, input, output. The input was -2. The output was -2. That's just a pure coincidence. Then, so this one was the input here. And I'm drawing these arrows on purpose, and I need you to draw those arrows as well. And now this -2 is going in here. It's kind of a little bit of a mapping. And I'm going to show you this mapping on the board in a moment. Actually, no, I'll show it with the next problem. But anyway. Now, Q of X was supposed to do a 2x squared, which in this case is 2 times -2 squared, because I'm plugging in that -2, which ultimately gets me that 8. It's a -2, 8. I'm going to leave this on the board for a moment, and I'm going to draw something up here. I don't know who taught you Algebra 1. I have no idea. I don't know who taught you pre-algebra. I have no clue. I don't know who these people are. But I believe, now I'll draw this a little higher. I believe that at one point or another, you have seen problems like this. I'm going to make this up, like 1, 2, 3, 4, 5, 6. You saw this in the past? No? Do you remember what they were called? Because I don't. I don't remember what they were called either. That's not the point of this.
I remember seeing them, but I don't remember what they are or how to do them.
I got you. That's no problem. That's not a problem. That's not a problem. I'm going to show you. Now, even if I don't know what they're called, I know how to use them. And I know what they're for. They're for a visual representation of a mapping. A mapping from input to output. A mapping from X to Y. A mapping from domain to range. Did you ever learn like the term a relation back in the day for math? Like when, maybe, yeah. Like, we'll talk. A relation is basically a mapping of inputs to outputs. That's all that it is. That's all that it really is. A mapping of inputs to outputs. And then determining whether or not something is a function, that's a different story. I believe back in the day, the definition that you may have been given for function was that for every input, there is exactly one output. You know, sounds somewhat familiar. It's been a couple years. For a lot of you. I know. I understand that. But all this stuff is related. Let me show you using a slightly different example. Let me show you using this one right here. Let's see. Okay. I'm going to use this as X, this as f of X, yes, and this as g of X. And basically, it's going to run through the gauntlet of this information. Yes, it's going to run through the gauntlet of this information. You're going to see what I mean in a moment. So, okay. Underneath here, I'm going to say that f of X is equal to 2x plus 1, and g of X is equal to 3x minus 4. Let's just say that. Give me a number. 5, sure. Doesn't matter what number we start with. That's just the number that we can put into the input. But the second that the 5 enters this mapping, stuff is going to happen to it. So once the 5 goes in, it's going to immediately be mapped to something in the f of X. If I plug that 5 into f of X, what do I get back? I get back 11. 2 times 5 plus 1. Yeah, I get back 11. Now, if I take that 11 and I plug it into g of X, into the 3x minus 4, what do I get back? 29? Oh, yeah. I didn't do the calculation beforehand. But you're right, it's 29. Yeah. There's a mapping from 5 to 11 and from 11 to 29. I can hear music. Can y'all hear music? Oh, I think it stopped. Anyway, back to this. Now, we can do this with any set of numbers. Give me another number, a negative number. -6, all right. Doesn't matter what this number is. If I take that -6 and I plug it into the f of X function, what is that? Oh, is that -11? Oh, snap. I wasn't expecting that. That was -11. Now I'm going to take that -11. I'm going to plug it into the g of X function. What is that? -37? Nice. But there's a mapping. I need you to visualize this. What I'm about to say. I need you to visualize this. What I'm about to say, is the general idea of composition functions. If I have to use first the f of x function. And I map it here and then map it there to the g of x function. Okay, that's no big deal. I could do it again with this number. To f of x to g of x. Cool, fantastic. What a composition does is it takes this middle mapping and it literally removes it. And it puts the first and the last one directly together. Think of a company where you work in the accounting department of this company. And you are given a certain input value where they ask you, hey, we need you to calculate this final result. But in order to get to that final result, you have to go through a series of calculations. First, you have to take the number and put it into the first equation. Let's call it f of x. Then you have to take that result and put it into the second equation, g of x. Then you have to take that result and put it into the third equation, h of x. And before you know it, you have like 7 or 8 different calculations that you have to do every single time they give you an input. That's going to take forever. I mean, it's not going to take forever, but it's going to take a huge chunk of time. So, being the clever accountant that you are, you line up all 7 equations, you figure out the order in which they have to be calculated, and you determine a composition of all of those equations. So instead of doing 7 calculations, you narrow it down to 1 calculation using the composition function. That is what this does. Now, like I said, I'm going to use these numbers again in a minute. But instead of going from 5 to 11 to 29, I'm going to go straight from 5 to 29 without skipping a beat. But first, I actually have to put together the composition. The composition in this particular instance, since I'm doing f of x first, the composition is g of f of x. It's g of f because the function that you perform first is on the inside. So g of x is supposed to be 3x minus 4. That's my outer shell. And what goes inside is the f of x function, in this case, 2x plus 1. Now I just have to simplify. If I simplify that junk, it becomes 6x plus 3 minus 4, or just 6x minus 1. Instead, and I'll draw the picture on the board so that we can actually see it. I'll draw it over here. We went 5 to 11 to, what was the last number? 20. Oh, was it 29? We went 5 to 11 to 29, right? Cool, cool. Plug in a 5. What do you get? Plug in a 5. What do you get? You get 29. It eliminates the middle steps. It takes these 2 different calculations, the f of x function and the g of x function, and it combines them in such a way where all you have to do is 1 calculation. And like I said, imagine working for a company, and not that you have to go through just 2 calculations, but like 7 or 8 calculations before you actually get the answer. It would be, oh man, it would be a lot simpler if I could take these 7 or 8 calculations and just shove them together in a composition and just get that thing done. Yes, it would be. And then it went, what, -6 to -11 to, no, positive, yeah, -11 to -37, right? That calculation right there, that's what we did originally. But now, if I plug in a -6 right there, it jumps directly to the negative 37, like magic. That's what a composition does. It takes this mapping of numbers and it condenses it down to one step. It's amazing. There's so many applications of this thing. It's insane. In science class, in science class, I don't know, maybe chemistry or something like that. You guys measure temperature in like Fahrenheit and Celsius, correct? Do you measure it in anything else? Do you ever do Kelvin? Nice. All right, just for the sake of argument. Yeah. Here, fill this out real quick, because I got to write down my next thing. I just couldn't figure out where my passes were. There we go. Cool. So let's see what we got here. I'm going to have you guys try something. I have a challenge for you, a small challenge for you that I would like you to complete. Here we go. First, for this example, I'm going to give you f of x, which is x plus 1. I am going to give you g of x, which is 2x. And I am going to give you h of x, which is x minus 3. Now, what I would like you to accomplish with this, and I'm going to show you a couple different ways to get this done, but I would like you to complete h of f of g of 5. Now, this is a small challenge. This is a small challenge. The order in which you accomplish this problem. Move this up a little bit more. There we go. I needed to get it out of the glare. But the deal with this problem is a lot of different calculations and the order in which you get them done. If I ask in that particular order, h of f of g of 5, there is only one particular answer that you will get. The answer is just going to be a number. My question to you is, what will that number be? Take the next couple of minutes. I want to see what you get with this. Go. For those of you in the chat, in the live stream, if you think you got the answer, I would like to see your guesses. I would. Remember, the final answer is just going to be a single numerical value. Any guesses? Tell me. Well, remember I said it was going to be a single numerical value. It's just going to be a number.
Well, 2.
Just 2?
Yeah.
It's not bad.
Yeah. What do you mean? No, I knew it wasn't right. What do you mean by the single? I feel like single. There only needs one answer.
There's only one answer.
So it could be over a single.
It could be.
Is it?
No.
Okay.
Let's go through it piece by piece. This is the last thing I actually want to do today. I want to show you how to get this answer in 2 ways. It's the last thing I want to do today. Watch this. If I'm looking at this and they tell me to evaluate h of f of g in that order, I could do it as, well, first, let me evaluate g of 5, because that's the innermost thing. If I evaluate g of 5, that's 2 times x, 2 times 5, which is 10. Now, mind you, hold on.
Miss Schuler, please call the main office. Miss Schuler, please call the main office.
Then I am going to take that 10, and now mind you, that 10 is on the inside of the problem. In fact, hold on, let me come up to the board real quick. Let me draw something in red here. H of f of g of 5. That's too many. There we go. I just figured out that that g of 5, look what I'm doing here. That g of 5 is now a 10. So now the problem has been reduced to h of f of 10. So I have to evaluate f of 10 next. And if I look at that f of x function, it's x plus 1. Well, someone get that? It's got to be 11. So now let me come back up to the board. I don't know where you left off. That's all the notes I've taken today so far, plus this page. I'll need that back, though, at some point. That f of 10 is now gone and replaced with an 11. So now I have to evaluate h of 11, which is x minus 3, which gives you a value of 8. The answer is 8. The answer is 8. And like I said, that's just one way of doing it. I'm going to show you an alternative way of doing it in just a few moments. But the way that I just did it on the board is if you actually have to go through every single calculation, one at a time. And if you have to do that 100 times over for a company, man, that's a lot of extra work. Instead, I'm going to do this. I'm going to figure out h of f of g of x. H of f of g of x. First, I'm going to do f of g. F of g of x should be equal to the following. Notice what I just did right there. And I'm going to put the g of x on the inside. There's nothing crazy about that. There's nothing that simplifies there. That just becomes a 2x plus 1. But now I'm going to take that 2x plus 1 and I'm going to put it inside of the h of x. Someone get that? H of g of f of x should be equal to blank minus 3, which is this 2x plus 1, which simplifies to become 2x minus 2. That's what this function actually is. Oh, here, trade with that. That's the last one there. What number did I choose to plug in originally? What was the number that I just picked? I handed him my paper. I don't remember. There's a 5. The 5, right? 2 times 5 minus 2 equals 8. One calculation. Plug in the 5, get the 8. Now, what I've just shown you is a more advanced, crazy version of composition. But this is what they do. I don't know. Has anyone in here taken a computer programming or any level of it? No? Okay. Our school does offer certain levels of computer programming. And the idea of computer programming is you want to program something that works efficiently. You don't want to program something that's going to have to go through 7 or 8 different calculations before you get to the final result, input versus output. Instead, you want to program it in such a way where it's only going to do one basic calculation or minimal basic calculations in order to make the website or whatever the heck it is program run faster. And once you can actually get that finalized composition function, that finalized composition function takes into account everything that happened before it and just does one fell swoop calculation. It's really nice. I like it. Do you get that page? Cool. I mean, you could do 3 separate calculations every time, or you could do the composition once, and then all you have to do is one calculation. It's nice. This is going to lead us into the beginning of January. In the beginning of January, we are going to take the idea of this composition function and apply it to a new concept called inverses. That's going to lead us to the middle of chapter 6, and the middle of chapter 6 will be everything that's up to on the midterm. I'm so excited. Okay. Honestly, that's all that I wanted to get done with this stuff today. My intention was, well, if I could at least get like a solid half hour or so, then so be it. And if I can get that solid half hour, then I'm going to high five myself and we're going to do something else then. So with the time that we have left, I just want to do something silly and off topic. So if you would, please have those Chromebooks out and open. And for those of you in the chat, of course, you can also participate in this silly and off-topic thing as well. I'm just giving everyone in the class an opportunity to get those Chromebooks opened and logged on. Just out of curiosity, how long is the battery life on those things? 10 minutes? Of course he's lying.
It's pretty long. Like, I use mine all day and it's still like halfway charged by the time I leave.
Mine's on 81% right now. It says there's 7 hours.
Well, keep in mind, that estimate is based on what you do in the next 7 hours, obviously. You know, obviously, if you're using it nonstop, maybe it would last 4 hours. You know, I don't know. It depends. Okay. While you're finishing logging on, I'm going to ask you to go to a quizzes. I'm going to ask you to go to a quizzes. And I'm going to get something loaded up right here. There we go. And start live one. And get rid of redemption. And flip that over. There we go. Duplicate. Yes. Because I know. So for those of you in the chat, I know you can't see the number, but I'd still like you to participate. So I'm going to type in, boom, type in the code right there into the chat. So if you can look into the chat, you can see what the code is and you can log on as well. You know what's really cool about the world we live in nowadays is that that new Pixar film is going to be released on Christmas on Disney Plus. Soul. Yeah. Yeah, on Christmas. You have to have Disney Plus. Oh, good question. Like Mulan. Yeah, they got rid of that. They got rid of that. Mulan, now you can watch. Yeah, and then Soul is going to be not premium. Well, what happened was they released Mulan on Disney Plus, but they were like, hey, if you want to watch Mulan, you got to pay like an extra like 15, 20 bucks. Because it was supposed to be like a premium thing. Like it's like if it were released in theaters. And what ended up happening was people didn't watch it. Yeah. Right? So I'm saying, you know. So that's, you know, what happened. But anyway, I'm excited for Soul. My family has been, me and my wife and my kids have been once a week watching a Disney movie that my kids have never seen before. And we've been doing this for 10 months. Yeah. Well, it's like, we got to do something to pass the time. Anyway. Make sure you're logged in. There's only 9 people logged in, but there's like, what, 11 people in the classroom. All right. Psh, you're going to miss out. All right. I'm not going to tell you what the theme is of this thing just yet, but if you want to join, once after I click start, the code should be at the top. What? Regardless of what you celebrate, I mean, you know, there are still movies that people see. Question, because I don't know the answer to this. Is Kwanzaa on a single day or is it spread out like Hanukkah is? That's what I think. Yeah. I thought it was something similar to that. No, I know. I just didn't know if it was like on a and it changes every year, right? Like the dates that they celebrated on? Okay.
Scrooge isn't the film. It's a Christmas carol.
There is a Christmas movie named Scrooged.
Yeah, but it's not the picture. That's not the picture.
Ah. Are there many? Okay.
Some of them are really hard to figure out. So really, it's fun while we can go, "Who's doing trees?" Oh.
There we go. Wait, so I gotta see that question that you're referring about.
You could run along with
I didn't make the questions, mind you.
Well, the whole, they have different people. I know Home Alone 3 is totally different.
Wait, was it this one? No.
Yeah, there's only.
Was it this one?
Yeah.
Oh, they accepted both.
That was you put both together wrong.
Oh, for real?
Yeah.
Oh, that sucks. All right.
Yeah, I think.
It was the first one. Okay. I don't know. I didn't get that. All right.
Did you make that?
No. Who won? Oh, they tied. Well, they didn't really tie. They had almost the same thing. All right, cool. That's fun. Nah. Oh, I don't even know. All right. Where is he? Where is he? Ryan. Pick a new topic. Pick a new topic.
New topic?
Yeah. All right. Pick a new topic.
Halloween.
Sure.
Alright, fine, Africa.
Yes.
All right.
I just wanted to say I'm gonna lose. I know that.
You don't.
I think most of these are going to be like geography.
Oh, definitely.
Even worse.
Not that.
Nice.
Not that.
Yes,
You
you
like-
think
you
red.
Oh, yeah,
like
do
pop
geography.
culture?
Geography?
Do a
Rap
geography.
music.
No, pop culture. No.
Oh my god. No one might do this idea.
Why? I'm so bad at geography.
Yes.
I'm like decent with
Say,
geography.
say, African geography. Exactly.
African.
African geography.
Oh yeah, we love that.
Hold on, I'm just looking at these geography quizzes. I'm looking at like what questions are with them. All right, nah. We'll do a shorter one. We'll do this one. Click. There we go. Again, for those of you in the chat, I'm going to type the code into the live chat so that you can join in if need be. What's the code? It is 486490.
Whoever is the best.
486490. There we go. At geography. My wife is no good at geography. We were live streaming the election, and she was filling in the map for me, and she couldn't, like, when I told her, I'm like, oh, Wyoming just went, and she's like, which one's Wyoming?
Like I know what's on the East Coast and the West Coast, but
come on. You got to know where stuff is. All right. Like I said, I'm going to click start. But if you haven't joined, the code should still be at the top of the screen. Click. Should still be at the top of the screen. Again, I didn't make this. I literally just found it. All right, now who is that? Yeah. What's that? What? All right. I don't watch those. Well, it looks like somebody might pass you. Oh, there he is. He's taking his time. Can he do it? All right. We'll do just one more. Only because I thought that one would actually last a little bit longer, but we'll do one more and then we'll call it a day there. Paul, pick a new topic. Pick a new topic. Let the man think. All right. Again, I haven't made these, so I have no idea what's going to happen. Oh, wait, no, that's not music. Sorry, I clicked that and I saw like a president question immediately. All right, I found a 2010 music quiz then. Again, I have no idea what these questions are. I have no idea whether or not these questions are accurate. 584851. 584851. But this will be the last one we do, and then we're going to call it a day. I got done what I needed to do. I'm going to knock some of these out for fun. Bell's going to ring in approximately 3.5 minutes. So let's get logged on, knock this one out. It should only be like 10 questions or so. So like I said, if you haven't logged in, the code should be at the top of the screen after I click start. 584851. Oh, wow. There's only 10 points separating it. 10 points. I don't even know what that means. Is that like a half a second click?
Pretty much, yeah.
All right. There we go. So,
Because no one saw you.
like I said, when we come back, we are going to be hitting the ground running with this information, heading towards midterms. I won't see you again until Tuesday the 5th. Oh, I'm sorry. I didn't. I don't control that. Hold on. That's the best I can do. I don't know. Anyway, I'm going to sign off. We'll figure it out next time. Yeah, I don't control when that